Now this topic talks about ki why we prefer CNNs over feed-forward neural networks. So architecture of CNN is basically inspired by organization of visual cortex. Now what is visual cortex? Visual cortex is some part that is responsible for recognizing the image that is captured by your retina. In very simple words, very crude terms, this is the function of your visual cortex. And the connectivity pattern of the neurons, जैसे ह्यूमन ब्रेन में होता है, सिमिलर फैशन में CNNs में होता है. सो अकीन मीन्स सिमिलर टू समथिंग. अकीन ये वर्ड का मतलब है सिमिलर टू समथिंग. सो द इंडिविजुअल न्यूरॉन्स, they can only respond to the stimuli in small area of the visual field which is called as receptive field. So एक particular field में ही उनका response located रहता है rather than the complete field. A group of similar fields will encompass the full visual region if they overlap. So image क्या होता है? Image is nothing but it is a matrix of pixel values. We have already seen. अगर मेरे पास 3x3 इमेज है मैंने उसको किसी वेक्टर में कन्वर्ट करना है, आई कैन इजीली कन्वर्ट इट इनटू अ वेक्टर. सो अ 3x3 इमेज कैन बी इजीली कन्वर्टेड इनटू अ 9x1 वेक्टर. आई होप द कंसेप्ट ऑफ मैट्रिक्स एंड अ वेक्टर एंड अ टेंसर एंड अ स्केलर इज ऑलरेडी क्लियर. ओके, यूनिट 1 में हुआ था बट इम्पॉर्टेंट है. In the cases of extremely basic binary images, the method might show an average precision score while performing the prediction of classes, but would have a little to no accuracy when it comes to the complex images, having the pixel dependencies throughout. Now what happens is, whenever you take an image and you try to perform something with it using normal neural networks or feed-forward neural networks, बेसिक बाइनरी इमेज में आपको एक्यूरेसी मिल जाता है. बट जैसे इमेज का कॉम्प्लेक्सिटी बढ़ने लगता है, यू हैव अ कलर इमेज, यू हैव अ मोर कॉम्प्लेक्स इमेज, यू हैव इमेजेस व्हिच आर हैविंग डिफरेंट डायमेंशंस, देन दीज फीड फॉरवर्ड न्यूरल नेटवर्क्स कैन नॉट डू जस्टिस टू दैट कॉम्प्लेक्सिटी. एंड दैट इज द रीजन वी नीड समथिंग एक्स्ट्रा, एंड दैट एक्स्ट्रा इज नथिंग बट योर कॉन्वोनेट्स या CNN as we call it. Now your CNN is able to successfully capture the spatial as well as temporal dependencies. Spatial means space related, temporal means timing related. Okay, how is it able to handle these dependencies? Very plainly, it is able to handle these dependencies by application of relevant filters. We have already discussed कि your aim changes, your filter is going to change. ब्लर करना है इमेज को, एक फिल्टर यूज करो. एज डिटेक्शन करना है, दूसरा फिल्टर यूज करो. ओके, सो दिस आर्किटेक्चर परफॉर्म्स अ बेटर फिटिंग टू एन इमेज डेटा सेट ड्यू टू द रिडक्शन ऑफ नंबर ऑफ पैरामीटर्स इन्वॉल्व्ड एंड रीयूजेबिलिटी ऑफ द वेट्स. नाउ व्हाट आर वेट्स? आपके कर्नल में जो वैल्यूज है, आपके फिल्टर में जो वैल्यूज है, यू कैन कंसिडर देम एज योर वेट्स. व्हाट डू यू मीन बाय रिडक्शन इन नंबर ऑफ पैरामीटर्स? This is my image. If I try to represent this image in H into W into D, okay, how will that representation look like? 4 into 4 into 3, right? So this is the dimensionality of the image. Now when I apply a filter and I get an output image, don't you think the dimensions of that output image are lesser? So automatically number of parameters involved are reduced. It is better to work with less number of parameters anytime. Okay, now whenever we are talking about RGB image, why do we have 3 color planes? Because one color plane belongs to R, that is red color, second belongs to green color, and the third belongs to blue color. Now obviously बहुत सारे color formats available and you can have images in all these color formats, whether it is RGB, HSV, CMYK or it is a grayscale. And especially when you know you can imagine कि जब images बढ़ जाते हैं and you have to deal with very high dimensions, how difficult it can be to deal with those things computationally also and conceptually also. So basically CNN का जॉब क्या होता है? जॉब यही होता है कि ये डायमेंशंस को, इतना मल्टी डायमेंशनल इमेज है, उसको थोड़ा ईजियर सिंपलर फॉर्मेट में लेकर आओ, बट कहीं पर भी डिटेल्स नहीं जाने चाहिए. You still want the information. You still want the information that will help you in the prediction, that will help you in the classification. You want to preserve all the elements, but you want to compress the image into a format where, making a decent prediction is easily possible. So this is critical for designing an architecture that is capable of learning features while also being scalable to larger data sets. बिकॉज अगर बहुत ज़्यादा डायमेंशन के इमेज के साथ आप काम करने लगते हो तो आप छोटे डेटा सेट्स के साथ ही काम कर सकते हो. जैसे ही डेटा सेट बड़ा हो जाएगा, यू वोंट हैव दैट मच कंप्यूटेशनल कैपेबिलिटी विथ यू. सो वट एवर इज द जॉब ऑफ दिस CNN, इट इज़ वेरी क्रूशियल, especially when you want your algorithm to work with huge data sets. Now the next concept is how exactly is the convolutional operation done. So as I told you earlier, we had seen in unit number 1 also कि convolution is a specialized kind of linear operation. It is an operation on two functions of real valued argument. So basically ये दो functions कौन से हैं? That is, one is your image, another one is your kernel. Okay. So convoluts are nothing but they are simple neural networks that will use convolution in place of matrix multiplication. Okay, at least one of the layers in the neural network एक जगह पे matrix multiplication के जगह पे convolution का concept use हुआ है. Now I continuously kept on talking about कि your filter is going to be different. Then your image will give you different results. So what exactly that means? That simply means that the values in your filter will be different depending upon what you need to perform. So if you want to keep the original image as it is, this should be your filter, the first one. I want to blur the image, then this is what I am supposed to do. I want to sharpen the image. Can you see how the diamond shape values are negative, but the center value is positive? Edge detection. All the corner values are negative, the center value is positive. And we have applied the filters on the same image. And you can see how the output is changing, how the image is actually being blurred, how it is being sharpened and how the edges are identified. So basically ये जो kernel है या ये जो filter है, it is a basic 2D matrix whose contents are based upon what operation you want to perform. So ये image को sharpen करने के लिए ये kernel use किया, मतलब ये नहीं है कि सारे images इससे ही अच्छे से sharpen हो जाएंगे. You may have to update the values, you may have to change the values. Okay. Now a kernel maps to the input image by simple matrix multiplication and addition, and the output that is obtained is of lower dimension. As I told you earlier also कि हमारा main aim क्या है CNN use करने के लिए, कि जो high dimensionality है वो थोड़ा कम हो जाए. So obviously when I am applying the kernel on the image, जो output मुझे मिल रहा है वो lower dimension का. We have already seen it. We have seen the dimension of the image, dimension of the kernel or the filter, and then what is the resulting dimension of our output. So from that part it is very evident कि ऐसा ही कुछ हो रहा है. Correct? So that is one thing that you have to keep in mind. Now whether I want to smooth the image or sharpen the image, or I want to perform edge detection, you have sample kernels or sample filters that you can use. Now what should be the shape of the kernel? Shape of the kernel typically depends on the input image ka shape and architecture of the entire network, but majority of the times it has to be a square matrix. So maybe a 3x3 or a 5x5 or a 7x7 matrix. Okay. The movement of the kernel is always from left to right and top to bottom. Now this is okay if your kernel is 2D. बट अगर 3D है तो फिर क्या करोगे? If your kernel is 3D, then it will move from front to back, left to right and top to bottom for a 3D input matrix. So if your image is a 3D input image, 3D image, फिर front to back एक add हो जाएगा. Because अगर 2D है तो left to right and top to bottom में काम हो रहा है. But 3D के case में you have to go front to back also. Okay? Now let us see this via an example. Kernel movement, how does it happen? It simply happens कि input matrix is there, उसके ऊपर kernel place करो and the result is calculated. Now in very simple terms, अगर मुझे ये result यहाँ पे calculate करके देखना है, obviously I won't be doing complete calculations. You can just do it on your own later on. I'll just show you the first one. Okay, so I'm placing this kernel over here. So what do I get is 45 into 0 plus 12 into minus 1, so minus 12 plus 5 into 0, then minus 1 into 22, so it is minus 22, 5 into 10 is 50, so it is plus 50, and then 35 into minus 1 is minus 35, 88 into 0 is 0, I am just writing 88 into 0, then minus 1 into 26 is minus 26, then plus 51 into 0. I solve this. 45 into 0 is 0, so 0 minus 12, फिर 5 into 0 is 0, so plus 0, then minus 22, फिर plus 50, यहाँ पे प्लस साइन आना चाहिए, फिर minus 35, फिर plus 0 because 88 into 0 is 0, then minus 26 and plus 0 again. So finally what we get is minus 12, minus 22, minus 35, minus 26, plus 50. You can quickly try this and I'm sure the answer that you will get is minus 45. So the answer will be minus 45. So this is how we calculate the result. Now what we will do, our kernel is same and my stride is 1. So stride is 1, so I'll move left hand side by 1 place. This is where I'll consider my kernel to be placed, and then 103 will be the answer. Then again same kernel, but I'm coming towards left and 1 step down. So this violet color area is the area that is of your interest now. You will place of your kernel over here, apply the same multiplication, you will get minus 96. Okay, and same thing happens when you again move to the right hand side. I have shown you how this calculation happens. Okay. Now sliding window protocol, what protocol are you going to follow? Firstly, kernel gets into the position at top left corner of the input image. So the starting position is always going to be this top left corner of the input image. Then it starts moving from left to right, calculating the dot product and saving it into the new matrix. So you go from left to right, you calculate the dot product, you keep on saving into the resultant matrix. This continues till you reach the last column. As soon as you reach the last column, what do you do? The kernel resets its position at the first column, but now it slides 1 row to the bottom. So it comes 1 row down. यहाँ तक आ गया, पूरा last column तक आ गया. Now it starts from left hand side only, but 1 row down. Okay. Following this fashion, again left to right and top to bottom movement happens. Step number 2 and 3 are repeated till the entire input image has been processed. And as I told you earlier only, if I have a 3D input matrix, then obviously your kernel will have to be applied in a different way. So front to back is the thing that will be added along to left to right and top to bottom. Now the next concept that we are going to do is of polling. Okay. Now polling, again, it plays a very important role in pre-processing of the image. What does it do? It reduces the number of parameters when the images are too large. Your image is very large, you want to do something, you want to reduce something in it, you go ahead and perform polling. So it is also called as downscaling of the image, which is obtained from the previous layer. So पिछले layer से जो भी image मिला है उसको और ज़्यादा downscale करना है आपको, then you perform polling. Now usually downscaling is or downgrading is something which we use negatively. Here we are not using it negatively, we are using it positively. This is a step that we want in our neural network. Okay, you can just compare it to shrinking the image to reduce its pixel density. So you have a concept which is called as spital polling. It is also called as downsampling or subsampling, which reduces the dimensionality of each map, but it does retain the important information. So what are the types of spital polling? So what are the types of polling? The very first one is max pooling. So basically इसमें होता क्या है? It is a sample based discretization process. The main objective is to downscale an input representation, and we try to reduce its dimensionality. Okay, so we want the features to be present. We want the features to be seen in our output also, but we don't want the original dimensions. Okay, so how is it done? And while doing this, we are going for an assumption that features are contained in a sub-region being. So what does it mean? एक छोटे region में जो भी numbers है उसमें से अगर मैंने एक number लिया तो भी वो feature capture हो जाएगा. Okay, in very crude terms, this is what concept is applied. Okay. So max pooling is done by applying the max filter to a non-overlapping sub-regions of initial representation. Non-overlapping means what? What we were doing in CNN over here, convolution के step में जो कर रहे थे, वहाँ पे overlapping हो रहा था. अभी आप बोलो कि मैम overlapping कहाँ पे हो रहा था, तो ये दो images देखो. ये first image का section है. Yes. अभी दोनों के बीच में मैंने अगर बोला तो ये रीजन ओवरलैप्ड है, so there is overlapping. Similarly, you can find the overlapping here and here also. These four elements are overlapped in both the images. Step number 2 and 3 में ये overlapping है. Step number 3 and 4 में ये 6 elements are getting overlapped. So there is overlapping in this step, but when I'm talking about polling, we are not going for overlapping subdivisions. Okay. So you can see this image is divided into 4 parts, and because it is max polling, what is done is इसमें से जो maximum number है that we have taken. Okay, so here 20 is max, here 30 is max, here 112 is max, and here there is a typing mistake. This has to be max. And that is what we have got over here. So a 4x4 image is converted into a 2x2 image. Okay. So what we try to do is, if these are my dimensions, I try to reduce my dimensions by downscaling, and still I get a similar output. You can see the output ki 224 by 224 when it was there, what was the scene, and 112 by 112 is there, then what is the scene. The next type is average. just as we calculate average, similarly we have to calculate the average of the region. So here we consider max number, correct? So instead of max, what we will calculate? We will calculate the average. So 12 plus 8 plus 12 plus 20 divided by 4. Whatever number comes, we will write it over here. Okay. Similarly, we can have sum polling or mean polling also. So जैसे max के लिए किया था वैसे यहाँ पर करना है, but sum के केस में then you will perform addition. So that's it for these two main topics.